Okay, so here's my legacy project. I'm Josh. Sorry you're not going to see my face, but it was just a little too complicated for me to do Loom videos like Papa Fitch. But we're going to go. I think this might be take 3. My brother just walked in while I was in the middle. Okay, so for my problem, I chose a practice problem from Unit 3. It's 10 grams of chlorine gas is bubbled through a concentrated solution of sodium bromide. And we need to, part A is to write a balanced chemical equation to represent the reaction, and part B is to figure out what mass of bromine will be formed using our answer to part A, using the balanced chemical equation. So I chose this problem because for me stoichiometry was the hardest thing I learned this year, and I'm pretty sure it's because of the way my brain thinks in solving algebraic problems. So for me it was just a little weird to wrap my head around the idea of stoichiometry, and we can talk about that a little bit more. But let me just get right into it. So, first we're going to start with the smiles technique, right? I drew a picture of it. We have a bottle thing with sodium bromide in it, and here's like a straw with chlorine gas, and I'm kind of bubbling it in, okay? So, first we want to figure out what type of reaction this is. Okay, so we have 5 types, but these first 3, synthesis, decomposition, and combustion, he would have used language in the problem, like he would have said synthesizes or decomposes, and there's nothing there. So I don't think it's either of those 3, but now we have single replacement and double replacement. I'm pretty sure because here you can see we have chlorine and sodium bromide. We have like 3 things. It's going to be single replacement because otherwise we would have chlorine in some sort of compound, but we have it on its own. So we're going to go ahead and say it's single replacement. Now let's remember the steps to BCE, to balanced chemical equations. We start by translating. Did that. I'll explain it. Then we're going to balance charge and then balance mass. Okay, so we have 10 grams of chlorine gas, plus sodium bromide. Okay, so, but then what does that become? We're going to go single replacement. And we know that chlorine and bromide, I'm looking at my little blue sheet, they have the same charge, and they're both nonmetals. So we're going to replace them. So it becomes sodium chloride and bromine gas. Okay, so that's our translate. Now we're going to balance charge. Okay, because we're using our blue sheet, I'm going to go ahead and tell you that both chlorine and bromine, they're called diatomic ions, which means that they, when they're on their own, in this case, when they're in gas, we're going to go ahead and write 2. And here, we're going to go ahead and write 2, because on their own, they're always in a pair, okay? But we're going to, or do we need to balance charge anymore? Sodium has a charge of +1, and bromine and chlorine each have a charge of -1. So we don't need to worry about anything there. Okay, we balance charge, and now we're going to balance mass. Okay, we have 2 chlorines here, 1 chlorine here. Okay, I'm going to double that. Okay, 2 chlorines here, 2 chlorines here. Okay, 1 sodium here, 2 sodiums. Oh, I'm going to double that. Okay, 2 sodiums here, 2 sodiums here. And then 2 bromines and 2 bromines because we have the Br2. Okay, so I think we're good to go. That's our balanced chemical equation. Okay, now the stoichiometry. How are we going to figure out what mass of bromine will be formed? Okay, so in stoichiometry, it's all about converting. So we're given one thing, we're given how many grams of chlorine we have, and we want to figure out bromine. So let's start with our given. We got 10 grams of chlorine, right? Let's write that. 10 grams of chlorine over 1, right? That's our given. Okay, now we're going to slowly convert into our bromine. So I'll explain that in a second. So basically we're doing kind of advanced multiplication, and we're going to try to cancel out each fraction. So we have 10 grams of chlorine as our numerator. The next time it's going to be grams of chlorine is going to be our denominator. And that's sort of how we move from each step to the next, so we can start to move towards our bromine. So that's basically how you do it. You're multiplying, but you're canceling out. That's the key to stoichiometry. So 10 grams of chlorine, and now we're going to figure out how many grams of chlorine is in a mole. A mole is basically a measurement of how many units of Avogadro's number, like 10 to the 23rd times 6.022. So it's how many, that's the number of anything we're talking about. That could be the number of molecules we have, compounds, whatever you're talking about. So in this case, we're going to use the mole to transfer. So our blue sheet tells us how many grams per mole is in a certain element. So chlorine, it's going to be 35.45. But if you see, we have chlorine gas, we have chlorine 2 because it's a diatomic ion. So 35.45 is going to become 70.9. Okay, sorry for that handwriting. Okay, 70.9 grams of chlorine per 1 mole of chlorine. Okay, and now we're going to transfer from moles of chlorine to moles of bromine. You see how we're kind of moving along? 1 mole of chlorine to 1 mole of bromine. Okay, and then last part, we're going to transfer from, now here we're going to go, because we switch, we have 1 mole of bromine on the bottom. And how many grams of bromine is in a mole? I'm going to go ahead and say, looking at my blue sheet, grams of bromine, 79.9. But again, we have a double because it's Br2. So it's going to be 159.80. So we're going to go ahead and say 159.80. And now we have our entire equation, and now we're just gonna multiply it out. So 10 times 159.80, it's 1,598, and on the bottom it's just 70.90, right? And so if we divide that out, it becomes 22.54 grams of bromine gas. That's our answer, folks, and it seems about right. We go from 10 to 22. It makes sense, right? 10 grams of chlorine, 22 grams of bromine. Thank you for watching, and I hope you understand stoichiometry just a little bit more.